Today's lesson is on square root functions, and so let's take a look at our first problem. And when we're dealing with square roots, one of the topics that we can solve using square roots is lengths of sides of a right triangle, and that's where we can use the Pythagorean theorem. And it states that any right triangle can be solved for one of the sides by squaring the two legs of the triangle. And the two legs are connected by this right angle system, this symbol. And that equals the square of the third side, the hypotenuse, which is opposite this right side, this right angle symbol. And so what they did on the problem is they went ahead and took the square root of both sides. So you see, if I take the square root of this side here, it'll cancel out this squared symbol. That's why you don't see it over here. And if I take the square root of this side, well, I've got to do the work underneath the radical sign first. And that's what we're going to do now. So we're just going to take this 8 and put it in place of A. Take 10 and put it in place of B, and then do the work. So now we have C equals the square root of 8 squared plus 10 squared. And so we go ahead and do some more work. Underneath the radical sign, we go ahead and square that 8 and get 64. Square the 10, we get 100. And this all equals 64 when we add those numbers. Well, later on, we're going to end up learning how to simplify the radical. But for right now, we can just pop it into the calculator and see what we end up coming up with. And so when we do that, we end up with an approximate value of C, because it's not a perfect square, but the approximate value is 12 and 81 hundredths if I round to the nearest hundredth. And so these are, don't know what the units are, so I'll just say 12 and 81 hundredths units. So there is our answer. Here we're supposed to find the domain of each square root function. Well, basically the domain are the possible x values. The domain represents x values. Well, remember, on square roots, we can only have numbers that are positive underneath the radical sign, or 0. 0 is the smallest number. You see, if we have the square root of -1, we don't have real numbers. These are not a real number. Later on, we're going to learn how we can come up with another number system and come up with answers for the square root of a negative. But for right now, we just say there are no real numbers for that. So what we're going to end up doing are finding the possible numbers we can put in for x. And so what we're going to do is take the number underneath the radical sign, just this. Ignore all this extra stuff over here. And so just take this 2 minus x and set it greater than or equal to 0. Because we could have 0 underneath the radical sign, because the square root of 0 is 0. So now we're ready to solve. So all we're doing is finding the domain, the possible x values. So I go ahead and subtract that 2 from both sides, and now I've got this. I've got the opposite of x is greater than or equal to -2. So what we're going to do from this point is divide by that -1, and we see that a couple things happen. First of all, we have x, but now it's less than or equal to +2. So the numbers that we can have in place of x have to be less than or equal to 2. And so those are the possible domain values. So that's what you're going to do on all these problems. You're just going to take the expression that's underneath the radical sign, just the stuff that's underneath that radical sign, and set it greater than or equal to 0. Because the values of x have to make this expression 0 or bigger. Otherwise, it's going to have a negative number underneath the radical sign, and we're not going to take a negative number in this class. Later on, we'll learn how we can. But for right now, we won't. And so we're going to subtract that 3 from all sides. So now we've got this 3x is greater than or equal to -3. So when I divide by the 3, note that I'm dividing by a positive, not a negative. So the inequality sign stays the same direction. X has to be greater than or equal to -1. So if you put a -1 in there, we get 0. If you put anything that's bigger, we get positive numbers. Anything smaller than -1, we get negative numbers, and we can't have that. So same thing here. Ignore all this extra stuff outside. We just care about the domain. The domain are the possible x values, so set them greater than or equal to 0. So we go ahead and do some work there. We're going to add that 3 to all sides. And so when we do that, we now have x is greater than or equal to 3, and that is our domain right there. Well, we're using this concepts so that we can graph. And the whole idea about graphing quadratics is to just come up with some values that make perfect squares. It'll make it so much easier. So think of perfect squares. The perfect squares that you want to come up with are 0, which makes 0, square root of 1, which is 1, the square root of 4, which is 2, and the square root of 9, which is 3. So those are the values that we're trying to think of to make underneath the radical sign. So on this one, the first step is to figure out what the domains are. So the domain, 3x is greater than or equal to 0. So that means x has to be greater than or equal to 0. So we're going to pick x values that are bigger than 0, but that tells us where to start. So the first value, and I'll come up with my little chart here to show what values of x I'm picking. I'm going to pick 0, the starting point of the domain. These are the possible x values you can pick, but they have to be bigger than or equal to 0. So when I put 0 in there, it cancels out this x, which makes this 0. Opposite of 0 is still 0. When I put the next number I want to make a 1. See, I want to make this 1 underneath the radical sign. So what I can do is off to the side, I'll show 3x equals 1. That's what I want to make. Well, if I divide by 3, that's how I get the number I need, 1/3. Now, I'll put 1/3 in there, but when I go ahead and put 1/3 in there, I get 1. Take the square roots of 1, but I take the opposite, which is -1 times by that number. So that's why I have to go down 1. Now the next number I pick, well, again, if you're not sure, just take 3x and set it equal to the number you want. You want a 4. See, this is the number I want right there, that 4. And so I go ahead and set it equal to 4. When I do the division, I end up with x is 4/3. So that's just 1 and 1/3. So that's how many spaces I'm going to go over. Now when I take that, I get 4, so I get 2. Take the opposite of that, makes -2. The next one, okay, now I need 9. So I'm going to set that 3x equal to 9. Well, I divide by 3 and I get 3. So that's the number I need. So I'm going to put a 3 in there. And when I do that, I get 9, but square root of that's 3, but I take the opposite, and that makes -3. So now I know where to plot my points. 0, 0, and then over 1 to the, well, 1 over 1/3. So here's 1 space, so over 1/3 is about right here, and then down 1. So down 1, so I've got a point about right there. And then 4/3 over. Okay, there's 2, but 4/3 is about right here, and then down 2. So I have another point there. And then over 3, and then down 3. So I got another point there. So you can see how it goes sharply down, but then it starts to even out. And so the next number is going to be off in this direction, so that's what the graph looks like. Let's take a look at our next problem here. Here again, this one's a little easier. It's just the square root of x. So these are the values we're going to use, 0, 1, 4, and 9. So let's go ahead and plug them in. So x, y values. So we'll plug in 0. Plug in 0 here. Square root of it, 0. Plus 2 makes 2. Plug in a 1, because the square root of 1 is 1. And add 2, that makes 3. Plug in a 4, you get 2. Plus 2 makes 4. Actually, I'm going to put a 4 here. Plugged in 4, I got 2. Plus 2 made 4. And then when I plug in a 9, plus 2, I get 11. So 9 here. And actually, I'm sorry, I forgot to take the square root. So square root of 9 is 3. 3 plus 2 makes 5. So let's plot these points. 0, 2. So I'm going over 0 up 2 spaces. And then over 1 space up 3. And then over 4 spaces. So we've got 1, 2, 3, 4. I'm going to go up 4 spaces. So I've got another point there. And then 9 spaces. There's 4, 5, 6, 7, 8, 9. It'd be about right here. I got to go up 5. So I got another point somewhere over here. And this is what the graph looks like. So that's what we have. And so it kind of looks like half a parabola on its side. Well, taking a look at our next one here, again, we try to find out where we start, the starting point, the domain. So take that x minus 3, set it greater than or equal to 0. And then you go ahead and solve. You got x is greater than or equal to positive 3 when I add 3 to both sides. So that's the number you're going to get when you plug in 3. You're going to end up with 0 underneath the radical sign. Well, the square root of 0 is 0. And so I know I need to come up with bigger numbers. So again, I can just test some points. So I can try, let's see here, we need a 4 underneath there. So I need to do x minus 3 equals 4. Actually, let's start with 1. because I want to come up with these numbers underneath the radical sign, 0, 1, 4, 9. So I want 1, so I need to add 3 to that, and that's how I get 4. So I put a 4 in here, and that will make 1. So we'll put 4 here. The square root of 4 minus 3 makes 1, so the square root of that is 1. And then I do the next one. So x minus 3 equals, I want to make a 4. So I add the 3 to both sides, so that's how I'm getting 7. So I put a 7 in here. 7 minus 3 is 4. Square root of that is 2. And then I do the last one. X minus 3 equals 9. That's the next one I want to make. So I have to add the 3, so I end up with 12. So 12 minus 3 makes 9. Square root of 9 is 3. So put a 12 in here, you end up with 3. So over 3 spaces brings you up 0. Over 4 spaces brings you up 1. Over 7, so that's 5, 6, 7, up 2. And then over 12, 7, 8, 9, 10, 11, 12. And then we end up going up 3 spaces. So we get another point there. So that's what our graph ends up looking like, just like that. Well, the last problem here asks us about more kind of like the first problem we had, where we're going to apply some of these radicals to an actual situation. So this talks about skid marks can be used to estimate the speed that a car was traveling. On dry concrete, the square root of 24x gives the speed in miles per hour. And the length of the skid mark is x feet. So if we plug in the number of feet in for x, multiply by 24, take the square root, we get the speed prior to them stepping on the brakes. So find the speed of the car if the skid mark was 60 feet. So we're going to put 60 in place of that x right there. And so now we've got this. We've got the square root of 24 times by 60. And so I multiply those two numbers, and I end up with 1,440. And so now we just plug that number into the calculator, and we get an approximate. Now I'll round it to the nearest hundredth. So I end up with 37 95 miles per hour. That is our answer. Well, those are the types of problems that you're going to see on tonight's homework. Good luck.